The most dangerous part of the B-21 Raider isn't its weapons. It's the invisible coating maintenance crews have to touch. This next-generation bomber is built to slip past the world's most advanced radar, and that invisibility comes from a coating so hazardous that crews need extreme protection just to handle it. One mistake during removal or repair can mean serious exposure, yet without this coating, the bomber would be easy to detect. This is why the B-21's stealth coating is deadlier than you think. What actually makes the B-21 invisible? The Northrop Grumman B-21 Raider is America's next-generation stealth strategic bomber, developed for the U.S. Air Force and expected to enter service later this decade. Designed to replace older long-range bombers like the B-2 Spirit and B-1, this platform combines a flying wing design with advanced materials and low observable technologies, making it extremely difficult for enemy radars to detect. A key part of what makes this aircraft stealthy isn't just its shape or internal weapon bays, although these are all advanced features, but it has a stealth coating applied to its outer skin. This coating is made of specialized radar-absorbing materials that trap and absorb incoming radar waves, rather than reflecting them back to enemy systems. By converting some of that energy into heat and dispersing it, these materials reduce the bomber's radar cross-section, allowing it to remain nearly invisible to sophisticated detection systems. It's highly complex, and not to mention demanding, to develop and apply these coatings. The compounds used must balance high radar absorption with durability and maintainability, and in many cases, it involves hazardous chemical processes. In older stealth aircraft, maintenance crew had to spend extensive time working with coatings that were really toxic and sensitive to environmental conditions. The Raider's coating systems are designed to be more resilient and easier to service than the earlier generations, but the underlying materials still need careful handling and specialized facilities to protect workers from being exposed. B-21 is fitted with cutting-edge stealth made by materials at the edge of technology. Before we discuss this, don't forget to subscribe to our channel for more coverage on the U.S. Air Force and its latest weapons. The materials that eat radar signals. Stealth coatings on advanced aircraft like this bomber rely on radar-absorbing materials which are engineered to soak up electromagnetic waves instead of reflecting them back to enemy radar. These materials are composites, where small particles that interact with radar energy are embedded in a supporting matrix holding them in place. This converts energy into heat, reducing the aircraft's radar signature. On the B-21, filled polymers are the foundation of the stealth coatings. Flexible polymer bases such as elastomers or epoxy resin are mixed with metal powders or ferromagnetic particles like ferrite or carbonyl iron. These particles can interact with incoming radar waves. This causes tiny magnetic oscillations that absorb the radar energy and dissipate it as heat inside the material instead of reflecting it back to the radar receiver. Another material is the ferrite materials, which are effective for absorbing radar at certain frequencies. Ferrites are iron-based ceramic compounds with magnetic properties that make them good at capturing electromagnetic energy. When this is combined with polymers, these particles can create a coating that can reduce radar reflections. Some modern variants are also expected to use nanoscale ferromagnetic particles or carbon-based additives. These improve absorption across a broader range of radar wavelengths by increasing interaction with the electromagnetic field. Using these high-quality materials, the USAF can make the Raider a game-changer in air defense. Stealth. Importance. The B-21 is being built as the backbone of the U.S. Air Force's long-range capability. This represents a major leap in strategic air power. Unlike older bombers that could be picked up by sophisticated radar systems, it is designed to operate deep inside contested airspace where advanced air defenses are the norm. Its stealth makes the aircraft so hard to detect that enemy radar returns are weak, ambiguous, and often too late to act on. This allows the bomber to enter defended areas with far greater survivability. Modern air defense systems deployed by near-peer adversaries are engineered to detect and track aircraft at long ranges. Without low observability, a large bomber would be detected early. This leads to rapid engagement and interception. Its low radar cross-section, achieved through its shape and advanced radar-absorbent materials, will reduce the number of supporting aircraft and electronic warfare assets needed to protect it. And let's not forget how stealth enhances strike options. By reducing detectability, this bomber can penetrate deeply strike with precision weapons, and exit contested zones before enemy defenses can respond effectively. This gives U.S. commanders options that older bombers simply don't have. In the strategic environment of warfare, protecting personnel and securing objectives will depend a lot on avoiding detection. That's where the B-21's stealth capabilities come in. But before we discuss its stealth capabilities of today, the USAF has a history of using toxic coatings for their craft. What were those coatings, and how have they changed to make the bomber stand out? History of toxic coatings. Smart technology was already taking shape in the 1970s and 1980s, as engineers always looked for ways to make military aircraft hard to detect by radar. Early stealth designs like the F-117 Nighthawk relied on special shapes and radar-absorbing coatings to reduce radar reflections. These coatings usually include iron-based radar-absorbent materials, which are tiny carbonyl iron or ferrite spheres suspended in epoxy. That absorbed incoming radar energy and converted it to heat, helping the aircraft appear nearly invisible to radar systems. They always kept the exact compositions as classified information because revealing them would help their enemies reverse engineer the technology. But because those materials are so secret, it had serious consequences. In the 1980s and 1990s, at facilities like Area 51, waste chemicals from stealth paint testing were burned in open pits to keep samples from leaving the base. They ended up producing toxic smoke that made the workers sick. To make things worse, the chemical makeup of the coatings was a secret, so affected personnel couldn't get the medical help that they needed. But when the USAF started developing the B-21 Raider decades later, engineers started to address these issues. The Raider's stealth coatings are built on less maintenance-intensive and more durable materials, based on decades of operational experience with earlier aircraft like the B-2 Spirit and the F-117. Because of this, its coatings are expected to need less specialized upkeep and fewer hazardous handling processes, while still providing low observable performance. Its stealth is made to bypass different radars, and it understands how these systems work. How radar works: radar systems detect objects by sending out electromagnetic waves and listening for the echoes that bounce back when those waves hit something solid. A large reflective aircraft sends a strong signal back to the radar receiver, allowing operators to see it on a screen. The strength of that return signal, called radar cross-section, will determine how easily an aircraft is detected. A big bomber might reflect so much energy that it's visible from hundreds of miles away. B-21 Raider is designed to reduce its radar signature so that the energy radar sends out doesn't come back in a strong echo. They do this in two main ways. First, the shape of the aircraft, with smooth contours and careful edge alignment, deflects radar waves away from the source rather than back to it. This makes its radar return appear much smaller. Second, its surface is covered with radar-absorbing materials that absorb and dissipate electromagnetic energy instead of reflecting it. These materials convert part of the radar wave into heat, leaving little to return to the radar receiver. Because the B-21's design reduces radar cross-section across multiple radar bands, enemy radar systems might not register it until it's much closer than a non-stealth aircraft. It might not be completely invisible, but it creates a near absence of detectable signal, allowing the bomber to penetrate advanced air defenses. The Raider's stealth coating solves the maintenance and human cost of previous fighters. But before we explore that, don't forget to hit that like button. Subscribe to our channel for all the latest insights into the U.S. Air Force. Why older stealth jets were a nightmare to maintain. Stealth aircraft, like the F-22 Raptor and B-2 Spirit, have long carried a hidden burden. Their radar-absorbing coatings are fragile and demand extraordinary maintenance. Older materials degrade quickly when exposed to moisture, rain, sand, ultraviolet light, fuel spills, and temperature changes. This erodes the coating's radar-absorbing qualities and will force crews to repair or replace sections. In the case of the F-22, the amount of work can add up to hundreds of hours of maintenance for every 100 hours of flight just to preserve its stealth skin. Much of that involves careful, labor-intensive handling of hazardous, radar-absorbing materials. These materials are so sensitive that even minor surface damage can reduce low observable performance and increase operational cost and downtime. Instead of relying on fragile surface paint that needs to be constantly stripped and reapplied like the earlier stealth aircraft, the B-21 uses more durable, maintainability-oriented RAM systems engineered into the structure and coating process. Defense analysts have said that one of the reasons why the Air Force is so confident in this bomber is its stealth materials. These keep the aircraft operational with shorter service intervals and without having to depend on specialized hangars or intensive manual labor. Its stealth coatings represent a significant step forward, but this has reduced the human cost involved in making these advanced aircraft. The human cost the Air Force couldn't explain. In the early years of stealth aircraft development, workers handling radar-absorbing coatings often face serious health risks with very little explanation or support. At highly classified facilities like Area 51 and other test sites, hazardous materials used in the coatings or their disposal were sometimes burned in open pits, creating thick clouds of toxic smoke. Workers who inhaled the fumes reported persistent respiratory problems, skin conditions, and other illnesses they believed were because of exposure to these chemical byproducts. In several cases, workers and their families tried to seek medical help, but the government refused to tell them what they were exposed to because of national security. Affected workers and widows tried to file lawsuits, but they were dismissed because of their limited evidence. After all, the government refused to disclose information about the chemicals involved. Today's maintenance crews working on modern stealth platforms like the B-21 radar operate under much stricter health and safety protocols. The Air Force and defense contractors now use advanced personal protective equipment, high-quality ventilation systems, and comprehensive medical monitoring to reduce the human cost. When producing leading fighters like the Raider, the USAF has figured out how to eliminate the maintenance challenges and reduce the human cost. The Raider takes advantage of the advances in coating applications, and so it's not as deadly as it used to be. How has stealth coating changed over the years to improve the B-21? How the B-21 fixed a deadly problem. For the B-21 Raider's stealth, the way its radar-absorbing coatings are applied has completely transformed compared to older aircraft. On earlier stealth jets like the B-2 Spirit, maintaining the radar-absorbent surface was labor-intensive and slow. This required crews to apply tapes and coatings by hand and spend a lot of time restoring the low-observable skin of the aircraft. Robot-assisted application of new materials has already started on some modern platforms to reduce this burden, cutting the coating application time from days to hours. With the B-21, Northrop Grumman and the U.S. Air Force built improved manufacturing and sustainment processes into the aircraft from the start. Advanced robotics and digital tools like augmented reality headsets are now used during production to support technicians and ensure coatings are applied precisely and efficiently. Here's an interesting twist. The Raider's stealth coating is a strategic weapon in its own right. While coating advances have reduced maintenance time and worker exposure, they make the bomber operate where others cannot. In future conflicts, this stealth advantage could mean the difference between mission success and failure, changing how strategic bombing is executed on the world stage. Why the B-21 changes the balance of power. The stealth features of the B-21 Raider are a central part of what gives it a strategic advantage over older bombers and most other aircraft in the world. It dramatically reduces its radar cross-section across a broad range of radar frequencies, and with this, the Raider can fly into contested airspace with a much lower chance of detection or tracking by advanced enemy radar systems. This low visibility combines next-generation radar-absorbent materials and a flying wing design that deflects and absorbs radar waves, making the aircraft seem far smaller or almost invisible to hostile sensors. Unlike earlier stealth aircraft optimized for frontal radar returns, this aircraft design focuses on all-aspect low observability. This means that its radar signature remains minimal from many directions around the aircraft. This allows the bomber to approach, penetrate, and exit heavily defended areas while presenting very limited radar reflections. This gives commanders more flexibility to conduct missions independently instead of relying on fighter escorts or extensive electronic warfare support. With these capabilities, the USAF can bypass the integrated air defense systems from adversaries like China and Russia, which use surface-to-air networks. The B-21 Raider is expected to lead trends in international air power and introduce future developments. What comes after today's stealth? The B-21 Raider is already fitted with advanced stealth, but the USAF is working on better systems that go beyond polymer-based radar-absorbing paints. Defense researchers are exploring advanced ceramic and nanostructured materials that promise better radar absorption, thermal resilience, and broad stealth performance. One major area of innovation involves nanotechnology-enhanced coatings, where engineered nanometals and metastructures reduce the radar cross-section more effectively. At the same time, they remain thinner and lighter than older coatings. These nanocoatings can be tuned to absorb electromagnetic waves across a wide range of frequencies, helping the aircraft remain harder to detect by different radar systems. Another promising direction is ceramic-based stealth materials, which retain strength and stealth effectiveness at high temperatures and under environmental stress. Along with ceramics and nanomaterials, graphene-based metasurfaces and other composites are being developed to maintain electromagnetic absorption. After decades of toxic trial and error, stealth has evolved into one of the most decisive advantages in modern warfare. So what do you think matters most for the B-21's future? Its stealth materials, its range, or the missions it enables? Share your thoughts in the comments. And if you enjoyed this deep dive, hit that subscribe button for more breakdowns on U.S. Air Force weapons and next-generation military technology. You should also check out our previous video on AMRAAM's replacement is coming, and it's terrifying.